to go ahead and start going over number 1. It's okay if you're still working. So it says the student plays the following game. He tossed 3 coins. If he gets exactly 2 heads, he wins $5. If he gets exactly 1 head, it's $3. And then otherwise he loses. On average, how much should he win or lose per game, or per play of the game? So really quick, I'm going to go ahead and draw a tree diagram for like this explanation. So on the first coin, he can either do heads or tails. And then from there, he can either do heads or tails. On the second coin, right? This is the okay. So this is the tree diagram for that because there's 3 coins, or flips 3 coins, right? So how many possible probabilities is he going to have out of 8, right? Okay, so now how many is he going to have that he could win $5 with? Well, that's if he's going to have 2 heads, which is going to be what, David? 4 out of 8. Okay, so this one he'll win, this one he'll win, and that's all I've got. Nope, there's one more. The second one? This one, yeah, there it is. So this would be 5 too, right? So that would be 3 out of 8. Okay, so if he does this first one, we've already said he loses $2, right? Okay, on this one right here, he gets 3. On this one right here, he'd get 3. On this one, he'd get, okay, so for 3, how many 3s are showing up here? 3 out of 8, right? And then how many 2s do we have? 2 out of 8. So now we're going to actually do the expected value. So that's going to be 5 times 3/8 plus 3 out of 3/8 minus 2 out of 2/8. And so when we put this into our calculator, we're going to get $2.5. Okay? And so we would say, like, as our statement, then in the long run, you should expect to win $2.50 per game, per play of the game. Okay, you always want to use this wording when you write out a statement. Okay? A detective figures that he has a 1/9 chance of recovering some stolen property. He works on a property, but does not get his money if he does not recover the property. The investigation will cost $9,000. How large should his fee be so that on average his fee will be covered? Okay, so first of all, we know that we're going to set this equal to 9,000 because it's going to cost him $9,000 to do the investigation, right? So he's going to spend $9,000 no matter if he recovers the stuff or he doesn't. But now he's got to figure out how much he should charge in order to cover that fee. So what is the probability of him not recovering this stuff? 8 out of 9. What's the probability if he does? Okay, so we're going to have an 8 out of 9. And we know that he potentially will lose $9,000, right? That he spends. And then we're going to add that to the 1/9 times the probability, or like him actually getting the stolen stuff back, right? And this is how much he should charge for getting stuff back. So now we're going to actually solve for X. This is his fee. So we're going to multiply this out. And then we would add, and this would be 8,000, negative 8,000, right? Plus 1/9 X And then if we want to solve for x on this one, we're going to add 8,000 on both sides. And so that's going to be 17,000 is equal to 1/9 x. In order to get rid of that 1/9, we're going to multiply by 9. Okay, so 9 times 17,000. I don't know that off the top of my head. So this man needs 153,000, needs to be charging 153,000 just in case if he doesn't recover it, right? So if I were to write a statement about this guy, I would say that the detective must charge a fee of 153,000 per case to expect to break even in the long run. And I hate the fact that we have to use this phrase, but you always want to talk about like expected value in the sense of future tense, because we know that by definition, expected value is the anticipated value at some point in the future. Okay. Says the Raceway Park, at the Raceway Park, your horse Stick in the Mud, wow, has a probability, okay, of 1/20 or 1 out of 20 of coming in first place, a probability of 1/10 of coming in second, and a probability of 1/4 in coming in third. First place wins 4,500, second place wins 3,500, and third place wins 1,500. It costs you $1,000 to enter the race. What is the expected value for you to race? Okay, so really quick. So we've got the options: first place, second place, third place, or no place, right? Because like you could get less, right? We're gonna worry about the money in a second. We got that. We got it. So if you do first place, you're 3,500, right? If you're second place, 2,500. Third place, you're gonna get 500. And then zero place, or like you don't place, you're gonna lose that 1,000, right? Is that right? Yep. Okay, so the probability of getting first place, probability of second, 2/20 or 1/10, right? And then third is going to be 1/4. And then what about zero place or no place? Say it again. Okay, and so we got 12/20 by doing what? From 20, right? Okay, so he said you add 1, 2, and 5 together and then subtract it, right? Okay, so now we're going to do the expected value. So we're going to do 3,500 times 1/20. And then we've got 2,500 times 2/20 plus 500. What's up? Yeah, babe. All right, so then we got multiplied by 5/20 minus minus 1,000 times 12/20. Okay, and then you're going to multiply all this mess out, and you're going to put it into your calculator, because we're not going to do that in our head. And we're going to get 175 plus 250 plus 100 minus 650. And so your expected value is going to be negative 125. Okay, so your statement at the end, because you're always going to ask to write a statement, if you bet on Stick in the Mud, many, many times, you expect to lose $125 per race in the long run. And sorry. So that would be like that sometimes. So this should actually be negative 50. So this is going to be $50 right here. So this is going to be 125 right here. And then minus 600. And so when you combine, you're going to get negative 50. Good catch. Gold star for David. If I had gold stars, I'd give them to you. I used to, but okay, so it says a social club has a drawing every Friday night. The probability of winning first prize is $100, and it is 0.002. The probability of winning the second prize is $80, is 0.01. How much should the club charge for tickets to enter the drawing so the club breaks even? Okay, so we've got $100, and the chance of that happening is going to be 0.002. And then we've also got $80, and the chance of that happening is 0.01, right? Okay, so we want the club to break even. So we want all of this mess to equal 0. So we're trying to figure out how much they should charge per ticket to break even. So we're going to have minus 100, because that comes out of the club, like, paying for it, times 0.002, minus 80 times 0.01. Yep. Okay, and then you're going to add X, which X is the price per tickets, right? With me so far? So remember, the club wants to break even, and they're going to lose money when they're paying $100 or $80 for those first place, second place people. Okay? So they want to make a profit. So we want them to break even off of these two things. So now you're going to have minus 0.20, and you multiply this out. And then you're going to have minus 0.80 plus X. If we combine our like terms, we're going to get minus 1 plus X. We're going to get X by itself. So how much should they charge per ticket? No, because we don't care. We just care about how much we're dishing out, right? If we're the club, we only care about, hey, I'm going to spend $100 and $80, but I want to make a profit. So I need to cover that cost, and then anything more than that is great because I'm making money, right?